Oh yeah, okay. From the continuation of my previous lecture. So this is representation of my uh, vector displacement. Okay. So that is usually this is an angle. No? So this is an angle of your theta. So that is equal to your the angular equal to the angular velocity times time. Now when I made first derivative of my displacement with respect to time, so that becomes velocity. So this is represented by this line, and that will be a dot 1 here signifying the first derivative, and it makes an angle of phi over 2. Now going back, so this is almost the same, no? This is phi over 2, that is in terms of radian. Now going back from my previous derivation of the equation, so we have here the values, which is the real part, no? That will be the angular velocity, amplitude, then cosine of theta plus your 90 degrees. So theta plus 90 degrees, so it means that we have here theta, and phi over 2 is equal to 90 degrees. Now to explain this one, phi over 2, so usually if I have my circle here and I have a given radius, okay, and make a line here, we have here the length of arc, okay, and this makes an angle of your alpha, or make an angle. Now if we're going to do some conversions here, going to the, from degrees to radian, so this is basically explains the ratio, no? So this is becomes the ratio of your angle, that will be the length of the arc divided by the radius. So this will become uh, in terms of radian. Okay. Now if I have, if my line rotates, or my vector rotates at sample at 360 degrees, no? Sample that one. So I'm just have to substitute this one here. I have here 360 degrees. Then this is equate to your length of your arc and divided by your r. So this is my region. Okay. Now the circumference of the circle, so this is 360 degrees, or length of your arc, circling that one. So this is the circumference of the circle, which is equal to 2 pi r, then divided by your r. Okay. And this is in terms of region. Okay. And usually I can cancel this one and this one. So I have now for 360 degrees rotation, so that is equal to 2 pi, no? And if I ever want to divide this one 360 degrees by 2, and this one divided by 2, so this is in terms of regions. Okay. And if I try to do that one, so this one will become 180, and this one will be 5. So it means that 180 degrees is equal to 5 regions. Yeah? Again, if I will further divide this one, 180 degrees divided by 2, so this will become 5 over 2, and this is now 90 degrees, and this is 5 over 2. So here we have now your 5 over 2. So if my first my displacement, if you're going to my rotational displacement or rotational vector, initially makes an angle of theta, or angular times the velocity. Now if I will make a second derivative of that one, first derivative, sorry, so that will make an angle, which is for my first derivative for my velocity, no? So this makes an angle of your theta plus, that will be phi over 2. Let's say that will be angular velocity times time plus your phi over 2. Now for my, this acceleration, no? So this is equal to, so let's try to go back from the previous. No? So here, that is cosine of theta. So we'll make a trigonometric identities for this one. So my negative, no? Negative cosine of theta. So this is equal to positive cosine of theta. So this is positive cosine of theta plus 180 degrees. Okay. Or we can express this one as your cosine. No? That will be angular velocity times time plus 100. Sorry, this is 180. So 180 degrees. Okay. Now we can rewrite my equations here for my real part. Okay, so that will be equal, no? So that will be, if this is negative, so it will be become a positive angular velocity squared times my amplitude. So multiply by cosine, and this is angular velocity times time plus my 180 degrees. Okay? And if we go back here, no, 180 degrees, so 180 degrees, it is equal to pi radian. No? So I can express my accelerations, so in terms of that one, so that will be theta, okay, plus your pi, or let's say that will be angular velocity plus times time, so that will be plus pi. So that is the angle of my acceleration, or my second derivative of my velocity with respect from the real part. Okay, real part, so starting from here, going there. So that will become my angle. So